here is to get rid of solid stuff that'll settle out. And the water comes bubbling up through the middle in that center mechanism, and then it spreads out slowly. Right now a handful of water is spending about 1 hour in here, but it's moving really slow, and you can tell how fast it's moving by how it's kind of coming over these weirs at the edge really slowly, and that's the water leaving the clarifier. And it just gets channeled to a collection point and then pumped to the next process. But directly underneath that skimmer, some stuff floats, not much, but we've got to collect it. On the bottom there's a series of rakes that plow the sludge into the middle, and then it collects it there, and we pump it to those cylindrical brick facade structures, and those are anaerobic digesters. And that's where the gas gets created to heat the plant and to heat the digesters themselves. So this is all physical, like Bert said, it's all gravity here. And then there's a, have you guys addressed the term biochemical oxygen demand in class yet? Anyways, it's just how much oxygen, the organic material left in the water will deplete oxygen because bacteria will metabolize that organic material and deplete the oxygen. So that's, in wastewater treatment, that's our big measure of effectiveness. Is how are we lowering the oxygen demand of the pollution in the water. We remove a lot of that oxygen demand is in the sludge, and it settles out, but it's only really about 30% of it. So some of the BOD gets removed, the biochemical oxygen demand again, but not a lot. We've gotten rid of the cheap stuff to get rid of because we use gravity to settle it out. Now the expensive part comes up because you've got barely, even though it doesn't look that clean, most of it's just coloration. You've got a ton of dissolved protein, sugar, fat, and we got to get rid of it, or if it gets to the river untreated, it'll deplete the oxygen in the river, fish will die, algae will hyperbloom, and we'll have big trouble. Our permit won't allow it. So you're faced now with how do you get rid of that dissolved material? The most effective way for cost is to set up a situation where bacteria can eat it and absorb it out of the water, make it part of their body, and then their bodies we can handle. So they assimilate the nutrients and food value particles and dissolved substances, make it part of their body, then we just let them die. You know, bacteria have a real high turnover rate, most simple organisms, so they live and die in a matter of minutes or days. So when their bodies can be collected and then sent to the digester. So that's the idea behind the rest of the plants almost. And the first place where we create a situation where bacteria and other simple organisms can thrive is in the trickling filters. Those are those 3 dome structures, the huge ones. We'll go over and look at